Okay, and welcome everybody as we continue on with the sections in the Technical Tools module. At this point, we've pretty much covered all of these kind of individual tools on their own, and for the next two sections, we're really going to be looking at kind of the strategy of how they get used together, the sequence of how we incorporate them as to best effect a transformation, and kind of some general kind of concrete examples of what a transformation can actually look like. So for this section, we'll be taking a look at implementation planning for lean transformation, which really covers a couple major milestones. So the first couple are going to be a review, just setting targets, the relationship between Kaizen and stability. Then we're actually going to look at a sample lean transformation roadmap, which is the bulk of this section. And then we'll finish it up with just a quick review on kind of confirming good activities and what a successful journey means. And then the last one, they're taking a look at how this idea of continuous improvement lets us and kind of directs our future activities. So the first question we always want to ask when we're getting ready and we're preparing to go on this type of journey with this type of transformation is, where do we go? And it's a good question, and to answer that, we do a lot of work at the beginning to set targets. And really what we're doing with that is we're developing a vision for this journey based upon whatever our current business needs are. And we try and quantify them in terms of who the customer is, what they want, when they need it, and in the quantity that they want it. And then what we want to do is, once we've kind of developed those ideas, is we want to really quantify those answers in terms of concrete metrics that we can communicate to the other team members and the other people that are going to be involved. And just as an example, a few examples of what I mean by concrete metric is something that we can measure. So weekly units produced, what our on-time delivery target is, labor hours, things like that. Something that can be measured and understood and is objective. And so once we kind of have an idea of where we're going, then the next question we really should ask is, how are we going to get there? And that's where we play on this idea of continuous improvement and the relationship between Kaizen and stability that we've talked about previously. But just as a quick review, before we start with a lean transformation, we want to make sure that the process that we're working on is first stable and repeatable. Once we have that, then we can plan and execute a Kaizen activity to improve it. And then we want to make sure, though, that after that we reaffirm stability so that we can confirm we got the results we were looking for. And it really kind of looks like just an iterative process of establishing stability, then a Kaizen event to level it up, reestablishing stability, and so on and so forth. And the key point out of this is that the stair-step approach is really what leads to sustainable continuous improvement, things that last once we walk away from them, and a shop floor that really manages itself. And so then once kind of understanding where we want to go, and then how we're going to get there, then the next thing we want to take a look at is what that road actually looks like. And that gets into this transformation roadmap that we talked about. And so just in terms of how we layer all these different technical tools on top of each other, this kind of review just takes a look at that ordering process, the best way to go about it. So the first thing we want to start with is a stable process, building that firm foundation. And then on top of that, we can layer on kind of the first couple skills, this idea of Hijunka, balancing load, leveling load. It's easy, kind of intuitive to see how that relates and depends on stability. Standardized work, developing standardized work, setting our standards, understanding how and why we're doing the things we're doing within processes. And then the idea of Kaizen, being able to find ways to plan events and eliminate that waste. Those are kind of the first three things that we want to layer on once we have a stable process. Then above that, we want to make sure that we have a good, effective problem-solving regimen in place, because good problem-solving lets us sustain the kind of base three skills and support stability. Once we've accomplished that, then we can really start tackling some of the more advanced and really some of the more advanced tools that people typically associate when they think of lean. The idea of just-in-time, pull systems, continuous flow, and then the idea of Jidoka, maximizing our human resource, separating man and machine, and then obviously incorporating the idea of notifying, stopping and notifying on the event of an abnormality. But once we've kind of established this framework and kind of built it in this way, then we're really in a position to realize our ultimate business goals with this, which is lowest cost, shortest lead time, and highest quality. That's what we're driving for. And so this actual roadmap, there's a couple steps that go into it that we're going to walk through. And the first one is grasping the current condition. Then we want to create stability. We want to develop our standardized work, deploy our ANDONs. We want to make sure that we've at least introduced problem solving by, after we've put ANDONs in place. Then we want to take a look at rebalancing and designing our work processes, looking at designing the actual work cells themselves. And then the last thing is introducing the pull system components to really tie everything together and provide the communication necessary for the entire shop floor to manage itself. So the first thing in grasping the current condition, we want to make sure we define the customer demand. We do that through the idea of takt time that we've discussed previously. Then we also want to make sure that we've defined all the KPIs that we needed to track our progress towards our target. This goes back to some of the things we talked about in the measurement module. Then again, we also want to make sure we've documented our initial MI flow to understand material and information flow through our process. That's covered in the measurement module as well. And then we can use this information along with the targets we set to quantify our existing performance gap. That is the gap that we want to try and close by converting our organization over to a lean processes. So then the next thing we want to do, the first tool we want to work on putting in place is stability. And to create stability, there's kind of a couple general things that we can do that work really well. The first one is we want to start incorporating our Heijunka thinking to start trying to level our production, right? Weekly, daily, hourly, whatever the case may be. And we also want to work on creating some sort of, in here it's called a sequence schedule for work processes. But what that really is some sort of mechanism where we can start to create expectations for the team members and their processes for what they should be working on and when they should be working on these things. To begin building that understanding of this is why I'm working on this and this is why I should be working on this. Then we also want to make sure from a materials handling standpoint and an inventory standpoint that we're sequencing our material handling with takt time, right? We want to make sure that we're not delivering material at odd times or the wrong time. So we want to make sure that that is included in this as well. And then the last thing, if we have excess inventory and in-process stock on the floor or in the process, we want to pull it back. If it's not needed right at that moment, we want to pull it back. And the reason we're doing these first four things is it's really a first big step to contain overproduction, which helps us create and sustain stability. Beyond that, there's a couple other things that we want to do. We want to make sure that we're documenting problems as they occur now so that we can start doing something about them, because good problem solving supports good stability. And then we also want to make sure at this point that we're collecting that data that goes into our KPIs so we can start tracking our progress. The other key thought out of this too, when we talk about stability, we talk about starting on this journey, we want to, from a cultural standpoint, start trying to shift the idea of our production processes as individual little elements and silos and convert it over more toward the idea of all these links in the chain working together as a cohesive whole. That is a little bit of a cultural shift, but it's important that we start making that now so that we're in a good place to support the higher level tools when we get to it. Then the next thing we want to do once we get started establishing stability is we want to move into developing our standardized work. And to do that, it's simple. Just create standardized work for current condition for each one of our processes. And really what we use with this standardized work, we can use weighted average times for a lot of different things, but that's a good way to account for model mix and option content if we have like a B-type system with a lot of variety. So the idea with standardized work is even if it's complicated, a lot of fluctuation and variation, we want to try and use weighted averages, standardize where we can, because we want to start trying to firm up an idea and create an expectation of the best way to do things and how long it should take to do those things. And so out of that, that's what we're doing. So the standard that we're creating here is, for production time, for the work sequence, and then also too, as a tool to help us build in quality. And just as a footnote on this one, I know it's listed as stability first, because stability really is first, and then standardized work. But in practice, a lot of times, it's easier and it comes pretty naturally to start developing standardized work while we're working to establish stability. They're pretty complementary. Then the next thing we want to move on to, after we put our standardized work in place, after we've started establishing stability, is develop our ANDON capability. And just as a quick review, There's two types of ANDON, human and machine. One of the things that I always like to stress is that we want to start simple. In terms of how we develop these tools and the systems, a good rule of thumb is, hold, tape, glue, weld. We don't want to start, like with an ANDON system, for instance, spending $1 million on a fully automated ANDON system until we're 100% sure what we want it to look like. So it's best to start with something simple, a flag, a light that's portable, easy to undo, easy to change, that can grow with us as we start to kind of define what's best for our application. Then in terms of functionality, there's a couple things that the ANDON does, which is why we need to incorporate it at this level. Most of this is a review. But it's a method for the operator of the machine to stop when there's a problem and make that problem visible. In essence, essentially, we're notifying our supervisor, whether that's the operator of the machine, a team leader, whatever. When there's an abnormality, we now have a mechanism to notify someone that something has happened. What comes out of that, why that's nice, why it works, is that it's visual. So we're now communicating these abnormalities visual, so we can see it. We can see status at a glance. It also provides a mechanism, because it's visual, to help create urgency in problem solving, because now it's visible to see how long that problem has gone unresolved, so we can measure that. We can improve kind of our response time to addressing problems that way. Then just purely from a quality standpoint, the ANDON really, as a mechanism, helps to prevent the flow out of defects, because it allows us to, when an abnormality occurs, to signal that there's been a problem, to have the attention come, have the problem resolved, and then the process can continue as normal, versus the traditional approach of doing the best we can and maybe just sending it down the line. Right? That's part of the benefit of having an ANDON at this point too. And then the last bullet there is it's a mechanism and it's a tool to support communication between management and team members. We don't have to go track people down or wait for someone to show up or wait for someone to make their rounds. Now when there's a need, an urgent need, we have a method for the team member to signal that they need support, and a method by which we can make sure that management is responsive and provides that support in real time. So that's why we want to make sure we have a good, robust ANDON system in place. It also happens to be the first principle of Jidoka there as well. Kind of that column. This is where we start working it in. The idea of stopping and notifying of an abnormality. Then at this point, we take a look and make sure that we have 8-step problem solving in place. We covered that in the module. There's a couple ways we actually deploy this. And the first one is we want to make sure that we introduce it to line management and make sure that they are competent and comfortable with what they're doing. The way we normally do this is we'll have management practice problem solving on real problems on the shop floor in a group setting, so that people can work together, learn the methodology together, get comfortable with it together, and then we can confirm that learning through individual problem solving tasks outside of the group setting. And then the last step is that we have management then cascade that learning down through the department directly to the team members. That's kind of how we allow these things and encourage these things to grow and spread organically. And it's much better, it's easier, and it supports the cultural transition much more effectively to do it that way. But as a quick footnote, because it is important to bring up, the sooner we can bring up problem solving, generally that's better. That's why in this particular program, problem solving really comes towards the beginning. This is really kind of the last place we would want to do it. This is the latest we can possibly throw it in. If we can get it in sooner, it's all the better for it. And so at this point, we've established stability, we've got our current conditions standardized work, we have our ANDONs in place, we have problem solving working. So in real time, we're starting to see the results of what we've done in terms of being able to maintain stability, and probably seeing that show up in some of our KPIs as well, just the benefit of containing the variation. Now to continue moving forward and to continue working towards our targets, the next step we want to work at is rebalancing our process. And this is where we start getting into some of the waste elimination efforts. And so what we want to do with this is we want to use our standardized work. This is part of the reason why we create it. And using that standardized work, which tells us the amount of value add being done in each process, we can find the total amount of time it takes to create our product from start to finish. And then using that, we want to create our work balance charts. And what a work balance chart is, it's shown there at the bottom as just an example one. is it shows the percentage of time in each process that is value-added work versus waste versus waiting time or walking time, and how that compares to what our customer demand is, or our takt time, to give us kind of a visual snapshot of how efficient our individual processes are. And then what we want to do is we want to use the work balance chart that we've got, we want to use our standardized work, and then we want to create new processes that have a higher percentage of value-added work in them, less waste, and when we do that, we can create a fewer number of individual work processes. So as we see in these examples, we initially had 5 processes, and each one of them was only about, on average, half value-add work time and half wait time. So those could be part-time processes, slow processes. The result is you either have a lot of team members waiting, or now management has to coordinate moving 5 people in and out. That's wasteful, that's hard to do, there's a lot of inefficiency, and you'll see that in KPIs and you'll see it on the floor. What we've done by rebalancing is now we were able to take those 5 processes and reduce them down to 2 that were stacked higher up, that were stacked almost to takt time with value-added work, and we eliminated 3 of those part-time processes. So instead of 5 half people waiting, people in and out, now you have 2 full-time people just doing the same amount of work. And one of the tools that we use to do this is a Yamazumi board, which this is an example shown there. And all the Yamazumi board is it's a way to physically represent standardized work that can be moved around easily to create new processes. So you can see the different colors and the big lines and bars on that, and really all that means is for each process, each work element within that process takes a certain amount of time. So on the Yamazumi board, processes that take a long time are tall, short time or small, and you can take that board and start at 0 on the bottom, takt time at the top, and literally just stack your work elements. And you start at the very beginning of how we work, and you stack, and when you hit takt time, that's one process. You go right and start the second one till you hit takt time. And that way that lets us structure all of our processes to takt time, so they're going to produce at the same rate. We can eliminate waste through that process, we make sure there's no waiting, we make sure there's no downtime, and we can come up with a more efficient structure for our processes that way. That's why we want to rebalance it. And this is one of those activities that maybe sounds a little daunting, but the first time, once everyone has had a chance to go through it 1 or 2 times, it becomes a pretty straightforward, pretty easy. There's not much to it outside of maybe a little bit of an intimidation factor. But it's very valuable because, as you can see, we go from 5 half-time processes down to just 2 full-time ones. It's a big deal. So continuing our work process design, once we've rebalanced it, now we want to look at kind of how we're laying out the entire process, remember, as a cohesive whole. And we want to make sure that we're designing our processes around the ideas of continuous flow, one-by-one production, eliminating silo building, and building in quality at each one of the processes. And so by eliminating silo building, what we're really talking about is individual processes that are kind of on their own little island, and they just build to in-process, they just build the stock that someone else takes from them later. And so what we want to change is getting away from building that inventory to just building what we need when we need it in the right amount. And so kind of as an example, what that looks like is here, before continuous flow implementation with silo building, they would just build and put inventory in a corner, and someone else would come take it when they needed it. With continuous flow thinking, with one-by-one building, we're able to eliminate that entire inventory cache. So that's a lot of inventory. It adds a lot of lead time to have that sitting there, and then you've also got quality issues, defect issues, rework issues, all sorts of things. So we want to make sure that our processes are structured so that we're minimizing our inventory and trying to reduce our batch sizes to as small as possible. Then beyond that, kind of the next step, now we can get into some of the more specifics of the actual work cell itself, the physical space of the work cells. And there's a couple key things we chase with that. One, we want to make sure that our work cells are ergonomic and safe. So it's an opportunity to fix issues with bending or reaching or potentially dangerous things. We want to use 5S principles for organization, which really all that means is just everything has a place, and a place for everything and everything in its place. So it makes it visible to see where tools should be, where parts should be, how your inventory is controlled, where the unit should be, where the operator should be. And that way it just makes abnormalities and problems visible because we've created an expectation of how it should be done, so it's easy to see when something is going differently. And the last one there is, again, this is one of the primary things we're chasing, eliminating waste in the process. So those are the 7 types of waste, and any opportunity we have to eliminate any one or combination of those by the physical layout of our workspace, we want to capitalize on. And just as an example, something like this. In this example, there was an opportunity to eliminate the waste of waiting by separating man's work from machine's work here to make the cell smaller, more compact, and make the process more efficient. And really what we did with that was we were able to free up people for more value-added work instead of the waste of wait time. Coincidentally, that's also the second principle of Jidoka. So you can see where Jidoka is kind of applied at a couple different points in this transformation. And then the last layer, so now just in kind of a quick review, we've created stability, established it, we've developed our current conditions standardized work, we put in place our ANDON system, we made sure that we had good problem solving in effect so that we were responsive to those ANDONs and we could support sustainable stability. Then we moved into rebalancing our processes. So we used our standardized work, we reorganized work elements, we combined processes designed to meet takt time, we designed them for continuous flow, so we got rid of inventory, in-process stock, reducing our lead time that way. Then when we laid out the actual cells, using our standardized work, using some of the things we've seen, we've designed our cells to eliminate even more waste through application of Jidoka or some other means, so that now we kind of have our physical layout done, our process is laid out, structured, designed, rebalanced, and we're stable and running. And then the last thing we want to add on top then is the pull system, the final way in terms of communication and inventory management that we can kind of turn this thing on and let everything manage itself, which is a real benefit. And so we do this because this then becomes our method of production coordination. And the key of how this works is that the removal of a completed product by the downstream process becomes the signal to produce. It's not schedules, it's not direction, it's not a member of management going and individually telling people. The line runs itself. And what we can accomplish with this is we can then, in practice, make sure that our pace of production of the entire line is matching our pace of sales exactly, which is what we're chasing in terms of ultimate efficiency. And just as an example of this, here in a normal condition, in this store, there should be 2 units there at all time. So when the store is full, up to its expected quantity, there's no need to continue producing those units. However, when a unit is sold or produced, and someone comes and removes 1 unit from the store, that then triggers production. So that's how we only build what we need when we need it, right? That's how the pull system coordinates and acts as the production schedule. And then the last step that goes along to putting in a pull system is developing and implementing KANBAN as the method of controlling your inventory and your production authorizations. And so looking at KANBAN, the first thing we want to do is we want to set up the work process KANBAN. So that uses lead time and parts usage to come up with the quantities. And then we want to make sure that all the KANBAN that we create includes kind of these following points. And there's really just 4 of them. And the key things that every KANBAN has to include is at least what to produce, the quantity to produce it, who's going to produce it and what that production sequence is, and then who receives it. So KANBAN can take any different type of shape or form. There's 4 examples shown here. It's customizable for every application, but we want to make sure it at least addresses those four key elements. And then the last thing, just as a footnote, is that when we use KANBAN, it effectively reduces our component lead time to 0 because we've created the material store and the finished goods store. So anytime anyone at any point in our production process needs any part, it's on the shelf waiting for them. That's what KANBAN lets us do. And so then, just as a review, this is the implemented structure that we've created. We started with a stable process, we incorporated Hajunka thinking, captured our current conditions, standardized work, we were able to plan and execute Kaizen events, supported all of that with our problem solving, then we could build on the elements of just-in-time, pull system, continuous flow, And then also we've been incorporating the ideas of Jidoka along the way, using our ANDON system to notify of abnormalities, and designing our processes to maximize our human resource by separating man's work from machine's work, with the ultimate goal of driving towards the lowest cost, shortest lead time, highest quality. And so once we kind of complete the transformation in terms of the technical tools we've applied, we want to step back, evaluate the results, and confirm that we were able to meet our targets. So we do that by simply reviewing our KPIs to see what they look like. Does the condition we're at now, does it meet the targets we laid out at the beginning? And then our future goals are driven by the answer to that question. So if there is a remaining gap, then our future goals are oriented towards trying to close that if it's still the most pressing business need. Or if it's not, then we can move on to something else. But the important key thought out of this is that the decisions we're making on what to work on and when is driven by the real data we're getting from monitoring our results and evaluating whether or not we're meeting our targets. And then one quick footnote on continuous improvement, kind of in this context. So just like our future goals and future activities, our future Kaizen work is driven by changing customer demand. And that change can be represented in a couple different ways. So it could be a change in takt time, sales, the pace of sales change, the cost for us to produce could change, our lead time requirements may need to change, and our manpower requirements may need to change, depending on product changes or a number of other things. And so because that is kind of what is driving our Kaizen work, we also want to make sure that we're challenging ourselves constantly in real time as we do this work to find new ways to eliminate waste, because at the core, that's what we've been doing with this entire transformation. And not surprisingly, not coincidentally, that really translates into kind of one of the ultimate goals of continuous improvement, which is we are always seeking to provide the customer with what they want, when they want it, and in that quantity we want it. And finding and eliminating the waste that prevents us from doing that is the continuous way that we work towards that goal. And so then just, quick for a quick reflection discussion. We started at the beginning with this, how do we figure out where we want to go? Where are we now? How do we use these tools? What sequence do we deploy them to kind of try and meet those targets? And really what we want to be doing that whole way is kind of monitoring our KPIs, checking our progress to see how we're doing. And at the end of it, these are typical types of results that we can expect, where before we started, for this example, to produce a unit was right at 40 calendar days. And then over the course of a year, the ensuing year, as these individual steps were taken, you can see where that lead time is steadily reduced. It doesn't all get reduced at once in one fell swoop. Remember that kind of stair-step approach where it's small, discrete, iterative chunks as we layer these tools on. You can even see where sometimes there were some struggles where we had to back up and reevaluate and try something, make some changes, and go forward. And why I like having this here is because it gives a real sense of what happens in the real world. It's not idealized, everything goes perfect. But as you can see, application of the thinking and finding creative ways to apply it and tailor it to organizations will yield results. And that's kind of the key takeaway. And they can yield results quickly and on a very, very large scale. And that's the real value of why we're pursuing this. And so as always, any questions, feel free to direct them to the website, and I will see everybody for the next section. Thank you.